Okay, our speaker today, Yuli Osterwalder, who is the principal and owner of Sun Protection Facilities, GmbH, and a member of the Swiss SCC. After studying chemical engineering at the ETH Zurich, Switzerland, and then at the University of Houston, Texas, he worked in industry, including at Ciba Geigy, Ciba Specialties Chemicals, BASF, and DSM. I guess there were a number of letter companies that you haven't worked at, but you found a number of them, right? He was also involved with ISO on the development of new UV protection assessment methods. Since 2006, he's been working on that, and he is now the chair of the technical committee on cosmetics, the ISO TC 217. He lives in the beautiful city of Basel, Switzerland. Well, welcome, Yuli. And I see we're at the top of the hour, so let's get started with Mary Lynn. Mary Lynn, you can take it away, and let me start up your presentation.
Oh, thank you.
Go ahead, Mary Lynn.
Well, hi, everybody. I'm Mary Lynn Halland. I'm the Secretary General of the IFSCC. I'm based in New York City. So if you hear any noise, that's New York City street noise. Let me just give you a very brief overview of who we are, what we do, and what's in it for you. The IFSCC stands for International Federation of Societies of Cosmetic Chemists. We just welcomed our 50th society last month, the Society of Cosmetic Scientists Nigeria. So we're a growing society, and we are thrilled to welcome our third society from the continent of Africa. We are dedicated to international cooperation in cosmetic science and technology. To find out how to contact the Society of Cosmetic Chemists or Society of Cosmetic Scientists in your country, go to ifscc.org and click on Member Societies. You'll find a map that looks just like this. Click on your country and the information will pop up. So a brief overview of individual member benefits. If you join your society's Society of Cosmetic Chemists or Scientists, and they're affiliated with the IFSCC, you're automatically a member of the IFSCC. It doesn't cost you another penny. You will get the IFSCC magazine, which we issue quarterly online. You can access cosmet.com, which is our online database of now almost 100,000 items of interest in cosmetic science. So articles, papers, all the full papers and posters from IFSCC conferences and congresses starting in 1995. This is the only place you can find them, and much more. At ifscc.org, we have a virtual library with reference books, textbooks, articles, all the same podiums and posters, and recordings of these webinars as well. You'll also have the opportunity to win prestigious awards, including those that we have especially for young scientists. We offer on-site educational programs through your national society, and everyone gets discounted registration to our upcoming Congress or conferences. And the amount you save on the registration is more than it costs you to pay your annual dues to your society, so it's really a deal. So that's it. The IFSCC, we're 16,000 scientists and growing to disseminate cosmetic science knowledge around the world and to have you get to know your fellow scientists. Thanks a lot.
Well, thank you, Mary Lynn. That's great. And Yuli, if you could come back on let's see, we're done here. The slides. Ah, there we are. Mary Lynn disappeared. Everybody's here now. Okay. There we go. So we're going to get started. Yuli, why don't you share your screen and we can get going now? But just one second before that. Okay, one thing I want to tell everybody in the audience. Well, this is a little bit interactive. If you have a question while he's giving a presentation in that chat room, type your question in there. And when he's done, we're going to have about 15 or 20 minutes to do a Q&A session. And if your question is in there, you'll have a better chance of it getting asked and answered. So be sure to post your questions in the chat room. I'll be monitoring it, and we'll be asking those after the presentation. All right, without further ado, Yuli, why don't we share your screen and let's get started.
Okay, I'm sharing it now. I go to
Presentation,
yeah. Is everything okay? You see me?
Everything's going? Yeah,
okay.
It's working and you're ready to go.
Yeah, so I first like to thank the organizers, the Swiss SEC, Petra Huber, and also Marilyn from IFSCC, and yeah, for this opportunity to talk about sun protection, especially the new SPF method, this alternative method. I gave this talk at another SCC event, or part of IFSCC, the German-speaking part. They call it the Forum Cosmeticum. Was going to be in Berlin last month, but of course it was also virtual because Berlin all of a sudden became a hotspot, so we all had to be virtual. And there I called it Sun Protection New SPF test methods make UV protection visible, wavelengths by wavelengths, because the whole topic was uncover the invisible. So it's basically the same talk, but it's about this alternative method. But first, I want to give you a disclosure. I was working for 20 years in the personal care industry before, as was said, as a chemical engineer in process development with these big companies, suppliers of UV filters. And now I'm currently a consultant, but I also am a co-editor of a book, a series of papers that will come out, challenges in sun protection, editing it together with Professor Surber, also from Basel. And I'm also the chair, as was mentioned, of the technical committee 217 Cosmetics. And in this, it was 2 years ago or so, we initiated a consortium that is now being formed, alternative SPF methods to actually test these new methods, comparing it to the gold standard. So I will also talk about that. So now first, let me start with the in vivo SPF that you all know. I mean, what we certainly know is that sunscreens work against erythema to prevent sunburn. And of course, the important part here is that the erythema action spectrum is really closely correlated with the skin cancer action spectrum. And that is also actually in the US, you have this claim, helps prevent skin cancer. In most parts of the world, of course, you don't mention that, but it's there anyway, because sunscreens are regulated as cosmetics, and you cannot make that claim of preventing or healing. And so that's how it started. The real sun was used first to generate the erythema and to test then the sunscreens compared to the erythema that you get without the sunscreen. And it's a complex process that is going on in the skin. And then after 24 hours, you're reading the inflammation that is occurring. And that's already the tricky part. Actually, it's complicated. You need people. I mean, they were even in the mountains there in 62. But then the reading is also very difficult. So there was, of course, from the beginning, an incentive to try to replace this, to have an easier method. Now it just, as we do it today, we have the sun now in the laboratory. And you see that the sun in the laboratory, of course, is not the same sun as we have it outside. It's especially more UVB, it's stronger. It doesn't have really the visible in it. And that already itself is making a difference. And as we will see, that was my title in last month. With the alternative methods, of course, we can then also extrapolate into these other parts where the laboratory sun is maybe not shining. Then we, together with Brian Diffie, we wrote an article there. There can be a big difference really, or let's say there can be a difference, factor 2 or so, between the labeled sunscreen SPF in natural sunlight compared to the laboratory sunlight, especially when it comes to very high SPF, because you can imagine when you have then more irradiation outdoors, right, then there's a different situation than in the laboratory. But this is not the topic today. This is maybe for later, but now we are asking ourselves, how can we match what is done now in the laboratory? And by the way, I just want to mention that as well. this is not was not a new idea of Brian Diffie and myself. This was actually already in an IFSCC magazine, 2001. The people from the Institute of Dr. Schrader in Germany, they already talked about this effect of having a difference between real sun and laboratory sun. And so the shortcomings today are this sun, which is not exactly the same. It's also invasive. It's very complex. You need volunteers. It's time consuming, therefore, and it costs intensive. And there's, as was just recently seen by this paper from Mixa, just a few years ago, the first really systematic study, there's quite a variation inter-laboratory. And so that's really a big problem when you have these test magazines, these consumer reports and so on that are retesting some sunscreen. Of course, they do it only once, and then maybe it has been done only once in the past, and these values sometimes do not match. Huh? You have all have experience with that, I guess. And that's another thing, what's happening. Not all sunscreen with the same SPF are actually created equal. So there can be an SPF 15. Here, this example from a publication we did some years ago. This SPF 15 can vary between 0 UVA protection, that means a protection factor of 1, or it can actually also be as good as the SPF, even be 15. In between, we have these various UVA indices, like the 370 nanometer critical wavelengths as a pass-fail for the US, the PA++ for the Asian countries, the UVA ratio there for Europe, the 1/3 criterion for Europe, and also the star rating in UK. The Boot star rating, 5 stars, is actually the toughest UVA standard that we have at the moment. And what I refer to as a spectral homeostasis would then be this 15, so that you have an SPF 15, you also have a UVA 15 protection factor. And that's what I call actually the ideal sunscreen that would uniformly protect over the whole UV range. And so that's now let's come to the alternative methods. Huh? And as you will see, they can actually, only they can detect these differences. What you saw before was actually simulations in silico. So now here we have an overview of the alternative methods. We have on the left-hand side the gold standard in vivo. There's actually erythema, and in the later there was also pigmentation, the PPD, the persistent pigment darkening, which is not actually the real pigmentation, but it's a chemical reaction of the melanin after a few hours, and not the real cascade of melanin being formed in the body. So the alternative methods are in vitro. That was tried even 40 years ago or so with the Bob Sayer formula. That was the first attempts to actually have it measured in vitro through a plate. And then came also in vivo. That's also quite an old method, but it was only developed to some matureness that we have now, the DRS, together with the ISO 2443, that's the UVA method, which is now referred to as the HDRS, together with in vitro in vivo. And in vivo, of course, not invasive. So this is not the invasive method as the current gold standard. And since for almost 2 years now, for almost 20 years, we have also simulation programs. We first had it out in the internet 2002 from SIBA. 2010, it was then converted into a BASF sunscreen simulator. And later at DSM, we also did it and call it the Sunscreen Optimizer. So you're probably familiar with these very useful tools for development of sunscreens. So the difference is there that we can also have all these alternative methods, actually, they can also measure the protection against the real sun because you just put in the sun spectrum instead of the simulated spectrum, instead of the laboratory spectrum. And any other metric, of course, can be calculated from these curves that you measure or you calculate. Okay. So let's go through these different methods. Just really brief overview. We cannot go into very much detail. This is a slide I also showed some years ago already. This is the status now where we have even robots and with 2 plates. That's the latest development in vitro. And it's now to a stage where it's also ISO, considered in ISO. So that's the in vitro that has come really a long way from 40 years or so. And then, but the major problem that still is here, that there's still differences to the in vivo SPF, that the plastic, the PMMA, cannot completely mimic the skin. Actually, I got this from John Sottery. He said the skin is not plastic. So this is the publication from this in vitro sun protection, the transmittance measurement. And you see here correlations, and I will come to that later when it comes to questions how to validate, how to characterize this method, so that we can really be sure that it can be replacing eventually, possibly, maybe the in vivo SPF. You see here, this is ISO CD, that's committee draft. So this is at the TC 217 committee level with all the countries voting. And this has got the number already that will then eventually also be the number of the standard for the SPF in vitro. And so now come to the next method, to this in vivo method, which actually is together with in vitro makes it a hybrid method. And this is the principle, and you have seen that the development really is has been done in the US. Nick Collias is really I think the man to mention here. When he has Mass General in Massachusetts and also at J&J. And so I know this method from him actually since 2001, I think. Not this method for the SPF, but the DRS. And it was first, of course, for the UVA. Because the problem here is that the UVB, you get no signals back in the UVB. It just stays in the body, in the skin. So that's why you then extrapolate this signal into the UVB with the in vitro signal, with the in vitro curve. And that makes it the hybrid method. And you see here from Schrader, for example, from the Institute Dr. Schrader, Matthias Rohr is here, the chief scientist, that they also have correlations. And you see the upper the correlation between these new methods and in vivo. And you see there's quite some scatter here when they account for the photostability of the samples. Then it's much better. So they also, because this is not invasive, so it doesn't actually take into account the whole dose of that you get in the gold standard. So that means you have to assess the photostability differently, and you do it like it is been done for the UVA in 2443. And so that's why this hybrid. And so you see also a very nice correlation here. And there is actually another method, which I would did before. I call it a monochromatic, or they call it a monochromatic. And here's another method from Solar Light Company, also in the United States. The people that actually make all these solar simulators, and they really apparently have noticed that there's something going on and want to go into some new business, which is no longer invasive. And that is poly-chromatic. That means it's all the wavelengths come at the same time. And they also have very good correlation. And supposedly, let's say that the potential here is to be much faster and at the more economic. That's, I think, the whole idea. And have an instrument which is smaller and makes it more economic to measure. So this is also in this stage of being tested at ISO. And so you see also correlations between in vivo and in vitro, and also for the UVA, of course. The UVA is that what you measure first, and then you extrapolate into UVB, and that gives you the opportunity to calculate the SPF. And there's actually a third method, which is now from Germany. I call it now, this is my invention more or less, multi-chromatic, because it's not poly or it's mono, it's actually about 8 LEDs that they use over the whole range of UV. So they fill in, and that's why I call it multi. And they also have a correlation, but there's not so much data yet. But they also, the idea here is also to have a compact instrument that then can be used to assess the SPF and UVA and so on. Right? So that's also in the game as HDRS. And then I come to in-silico. This, I don't think I have to go, it's just an overview of what we did. You're probably all familiar with that, but it's the first time now that we actually see this also a method that is analyzing, basically assessing samples that are not at all known. I mean, where the composition is not known. And so when the composition is not known, let's say somebody wants to use it to have a market monitoring or something like that, then you just have to do an analysis first. HPLC or some atomic absorption for the inorganics maybe, but you have to analyze first. And then you know the filter composition. And from then on, of course, you can just plug it into a sunscreen simulator or the sunscreen optimizer. And so that would be the process for using in silico when you don't know anything about the sample. And the how it works, the in silico measurement, you take the spectra from the sun, the erythema action spectrum, all the filter spectra, of course, and there's also a model. O'Neill was the first to write about this, a model of how the film, the sunscreen film on the skin looks like. And so all that together is actually then used to go into the SARE formula, which is like 40 years old, right? And then you calculate these curves. As I said in the other title, you make visible what is not visible. So what we did in DSM, actually, we expanded that from 400 to 500. So we kind of doubled the range. So we have the blue light, also the blue light protection immediately. And you got a nice summary here in this publication from 2015 that summarizes everything. But of course, there's a lot of other people also have been involved in developing this in silico method. And you see there's also a good correlation here from BSF 2013, about 100 points. Also quite a nice correlation. But I will show you that correlation is actually not the right way to assess the agreement of methods. So this was the sunscreen the sunscreen optimizer. Sorry, I showed this 3 years ago in Orlando, just to show you now how easy it is to look at these figures, at these curves. You see the filters here. This is just an example: octinoxate, oxybenzone, avobenzone 3% only in the US, right? And then bisoprolol, which is not yet allowed in the US. And so that was just an example here. Huh? And of course, you have all this regulatory information, everything you can calculate as UVA or whatever, you can have there, right? So that's really a handy, very useful tool. And it's also used a lot. I mean, I know the statistics, and I don't know it anymore, but a few years ago, there was already hundreds of thousands of calculations actually done. And now what I also did in Orlando, because it was in the US, everybody plays golf. So I was comparing playing golf and sunscreen development. So, and I learned this actually in a course in Florida when I started playing golf a bit. And they were teaching the 3 things: first, see it; second, feel it; third, do it. And so the see it in sunscreen development, of course, is the briefing, the strategy, the positioning of the product. And in golf, of course, for those who don't play golf, maybe in Europe or somewhere, you have to watch. I mean, you want to play over the water, or you want to go right to be safe, or what club you need, and how is the ball, and where is it, and so on. And then you do the feel it. In golf, you make your practice swing. Is it maybe half a swing or full swing, or maybe, and then you got a good feeling, and then you have to do it. But in sunscreens, you got this in-silico calculation tool. And so you can play around with percentage of filter, with different filter platform. And so this is really the part of feel it when you compare with golf, and to get an idea how what composition you should take. And of course, at the end, you just have to do it. And so now I go to the characterization of alternative methods. I mean, this was basically just a really brief overview of the methods that now exist. And this characterization, that's exactly the point where we are in ISO. This after, I've been there now for 14 years, actually. 2006 was my first meeting. And we always somehow discussed it, but never came to the really exact conclusion how we should actually do it. But so you see here, just go back to the in vitro, here a correlation, okay. But a correlation is not really a good method to compare two methods like here in vivo, in vitro. And I show you why. I mean, this has been discussed 35 years ago by Bland Altman in a Lancet paper. It's really a landmark paper, one of the most quoted papers in Lancet, where they compare how to compare methods, mainly in medicine. Maybe could be the blood pressure, could be the oxygen flow, or any measure, and where you always have new methods that you compare with the old one, right? And so what they said 35 years ago is that this correlation is still often used, but it's not the right thing. It doesn't give you the agreement. It doesn't measure agreement. It measures correlation. And if you have samples, points, values far apart, you got a very good correlation. If they are very close together, let's say all the SPF are around 20 and 30, then you get more scatter, and it's a very bad correlation. But it doesn't mean that the methods are worse. It's just a matter of how far apart basically these values are. And so that's when Bland Altman, as I said, 35 years ago came up with this right method, which is still the standard, the gold standard to compare, to test for equivalence. And so you don't just plot the correlation. You can do the correlation, but it's giving you an idea that it correlates, but not really the agreement. And what you plot is the difference between these two results of one method to the other. And you compare and you plot it against the mean value of these two. And that's how you actually assess a bias. Here, this red line is like 2 units above the zero. If the two methods match, if they are ideally agreeing, then this bias is actually 0. And you see that immediately. You have hundreds of points, and you see if this mean value is really at 0, or if it's 5 off to the plus or minus. So you see that. And you see also the scatter. So that's the precision. And if this is acceptable or not, that comes from outside. That doesn't come inside from the statistician. I mean, there's other criteria from other experts that have to decide on that. And now what we try to do in the ISO process and in consortium is to go a step further, not just agreement, but actually know why we differ. Where are the variations coming from? It's about repeatability, the different labs, the matrix, especially the products can be different in different methods, right? You all know that with inorganics, a lot of inorganics, you may have more problems with in vitro than with other products. So that's what we really want to find out now in this new test series when we compare the methods. And so that's the status. Just show you one slide, because there's hundreds and I think thousands of products in the market. So you have to have make it a bit systematic. And so these product types, you break them down as what vehicle or what format do you have? You have emulsions, which maybe it can be water in oil or oil in water. And you have emulsions with a high pigment fraction and with low. And you have solutions where you have alcohol or just pure oil solutions. And so what the experts now in ISO came up with is that what actually matters is what's left on the skin, the residue on the skin or on the plate, on the substrate with PMMA, for example. So in the end, it doesn't really matter if it was a water in oil or an oil in water. I mean, the water is just gone. And there is a liquid crystalline oil film then with low pigments. That's one type of product. And there could be a liquid crystalline oil film with high pigment fraction and maybe only pigments. And the other third one is lipophilic and high viscous or low viscous. So that's the idea here. I don't want to go further into detail because this is just being discussed actually in ISO. And so I cannot really go deeper here. But the viscosity is also one parameter that was identified that we should look at, high, medium, low. And of course, the different SPFs. I mean, obviously, it can be a difference between 50 plus and 6 to 50 plus. That's the range we are talking. These are the official categories in Europe. So, and so I want to just quickly go to possible acceptance criteria. As I said before with Plant Altman, that's what they said actually 35 years ago. It's the acceptance should not be determined by the statisticians, but comes from outside. And now what would be the normal criteria for SPF methods? I think, and that's what it's my thoughts really, that the SPF method should predict, for example, the EU label in this 95% certainty. And so what we have as a rough label is low, medium, high, and very high. This corresponds to different SPF categories. And that's the rule in the recommendation in Europe since 2006. And you see here, what I just did is we know that the ISO SPF method 2444, which was first published 2010 and now revised 2019, and first harmonized actually 25 years ago. And we always had this confidence interval for the mean value of plus minus 17%. And you see when you have these intervals between low and medium and high and very high, you have an interval of, let's say, of 40, 32%, 33, plus minus 20%. So I think there should be no problem with such a method to actually get this, to measure this accurately. And of course, the idea is that the alternative method should be at least as good as the in vivo methods today. That's kind of criterion in the air, but it's not nowhere officially written down. This is all what we're still discussing. And so when we go now to all these 8 categories, like 6, 10, 15, 25, and then 30, 50, and 50 plus, and we see that here it's getting a bit more narrow, and the plus minus 17, they cannot really distinguish, I would say, between 25 and 20 or 25 and 30. It's a bit too narrow, yeah. But okay, this is just as a food of thought, really, to think about it. And the experts will come up with some kind of acceptance criteria, because now we have the consensus that we should have that, right? But it's, as I said, not the statisticians that determine this. It's the experts, all the stakeholders, the ones that make sunscreen, the one that the authorities that actually overlooking sunscreens. Everybody, all the stakeholders should have a say here, I think. And now this was also the situation now. We have really an imminent breakthrough. Well, imminent means in a couple of years, maybe. And it took a long time, but I think we are really now very close. Because in ISO, we have now two numbers. We have at the committee stage, we have 23675. Talked first with in vitro, that was first, and then the HDRS with 23698. And so we're getting now kind of a toolbox, right? And in the consortium, we want actually to test these, to validate this method. Validate means we have to first to characterize it. And the validation, actually let's say the rubber stamp, that would then come from ISO. But the characterization is the most of the work. That's a ring study, comparing it with the gold standard. And so you have this HDRS, ABC, you have in vitro transmission, maybe also different methods, and also even in silico. And I come to that. This could even be some photography, but that's far away from being really a quantitative method. So I just want to give you this idea, this slide about how we work together, how this should be happening, this ring testing. So we have now three major stakeholders. We have the ISO, of course, that is developing high quality voluntary international standards. It's really all voluntary. And it's then up to states, up to companies, that suppliers and client relationships that make this kind of standard norm part of their contract, for example. That's when it becomes really official, an ISO method. But the ISO is here to just produce a norm that can be used then later for these other purposes. And of course, and we work, and then there's this consortium that was formed, came out of ISO to give all alternative SPF methods a fair chance to be evaluated. Because obviously the ISO has a focus on a few methods. It cannot just go and try to norm all the methods that everybody thinks it should be a norm. So these are really the norms, these two, the ISO CD 23675 and 698, that are now under consideration, and not more. But we, in the consortium, we want to look at more, and also Cosmetic Europe was helping now a lot to establish this consortium. This is the same interest. We want to go beyond what ISO is doing, and to help also and eventually get a toolbox of different methods. If you are interested in joining the consortium, there you can have a look at this website. We're still looking for some sponsors that actually make this ring test possible. This is not too much really, but it costs a little bit, and the whole value of this ring test is actually, when you calculate all the in-kind contributions, it's about $500,000 or euro or whatever. But this is the value of such a big ring study. And just to compare this $500,000 with the EU ban on animal testing, it's just, I got this slide from the European Union website, and so they were calculating for 20 years, over 20 years, they spent, or 25 years, they spent over $200 million, or euros actually, of course. Of course, we will never have this kind of dimension, but here it's about banning animal testing, and we are talking about banning, eventually replacing human testing. And so I think we should also have be able to raise a little bit of money to do this properly, and to establish and to replace this human testing, which is the gold standard, by good methods. So I also think here we should actually do it. And now we come to the last part. Measuring can really shape the future. If we know what has been invisible in the past, we can make progress with our sunscreens. And what we have available, I just wanted to kind of give this overview here. Maybe you can have two parameters that are always important: the accuracy and the costs. Obviously, we have the gold standard, which costs a lot and which is but it's a gold standard. It's that what we compare against. So the accuracy I put the highest. Then we have HDRS, which also costs still a lot. We just got a quote recently. It's a bit less than SPF testing, but it's a lot. And it's also in vivo, so it's bound to be also accurate. And there is these correlations that we have seen. And then there's in vitro method, which should cost less. And there is the in-silico, which should cost practically nothing. You just plug in the numbers and then you have the program for free. And I also put UVA photography. That's maybe certainly not so accurate. You just get the black face or black parts, and then it's a little bit grayish or less grayish. But it's really a good tool to have, for example, campaigns, or just to show that there is an effect of the sunscreen. And it should also be not so costly. It's just basically taking a picture with a converted camera. So, but I think each tool here, each of these methods will find an application. And this is really the toolbox we're talking later, right? And where certainly accuracy and costs always will play a role, and some other considerations as well. And so this is just to give you some also references of these alternative methods and giving the major advantage. For example, in vitro transmission, it's the major advantage. It's not in vivo. And the hybrid diffuse reflectance, one of the advantage is it is in vivo, but it's not invasive. And the in-silico, of course, it's very simple, very low costs. So this also gives you a very good value. And the UVA photography, as I mentioned, I used it myself in campaigns actually at BSF and also at DSM. We had these cameras, and were really a perfect instrument to show the effect and to make visible the effect of UV protection. So, and I think this is also used by big sunscreen companies, actually. And another thing I want to mention is, like, my hobby is this spectral homeostasis protection, which, as I mentioned in this slide, with the sunscreens not being created equal, right? So you can, for any sunscreen, calculate what is actually going through above this ideal. And when you have here USA Today, when you compare with the ideal, it's a lot of UVA going through. This is this blue curve sunscreen. It's mainly in the UVA1 where it's still going through. When you just calculate this in terms of absolute UVA, I mean, compared to the ideal. So it's then you have like 4 times as much, right? 370% more. Or in a very good sunscreen that you can have now outside in the rest of the world without US, it's still double, let's say 100% more. And if you come close, maybe you're not getting 100% exactly the flat line, but you come very close to the ideal sunscreen, then you maybe only 25% more of UVA1 transmission than with the ideal sunscreen. And of course, here, this last example is all broad spectrum filters, the BMT, MBBT, and the zinc oxide. So if this is a very good, aesthetically a good sunscreen, I have my doubts, but it just shows an example that that it can be done basically nowadays. And another example I want to show, this is actually the NGO in the US, the Environmental Working Group, how they used the publication of us with exactly showing this excess of UVA going through onto the skin when you don't have sufficient UVA1 protection, right? And so that's, I have to turn off the phone, sorry. So you see that this example that I had published a similar example about 5 years ago in this book here from Henry Lim and Stephen Wang. And so they used this figure in some of their sunscreen guide, to show that difference of sunscreen. And of course, now you can also reproduce this with the Sunscreen Optimizer or with the Sunscreen Simulator. You have this tool at your hand as well. So and so the Next example is a very recent one from this year. It's from Eduardo Ruvolo, who is also project leader actually of the HDRS method and developer of HDRS in ISO. And this is a paper actually challenging this 2-hour rules that you should reapply every 2 hours. Because now you can actually measure at the same spot 2 hours later. You don't have, it's not invasive, so you can measure 100 times. So you measure after 2 hours the same spots, and you get with multiple applications, for example. You see in this example that the SPF is actually rising. And if you don't only have a single application, you see that here this example from like 60 is going down to maybe 30 after 6 hours. And so this is not so bad. You don't have to reapply. 30 is still okay. So you see that these new options, these new possibilities with these new methods that you have now, right? So that's what I wanted to show. And here is my acknowledgement, is my former colleague at DSM, Jürgen Vollhardt, who is now very active in the consortium. And then the 3 statisticians, 2 from Quodata, Ulich, and Colson, and also Jose Carvalho from Brazil, and my colleague that we do the book together that should come out next year, Christian Surber. And so just want to show you that book should come out and will explain you much more of this whole topic, but many more topics. There's about 25 papers, which are actually standalone papers as well, but they will be retrievable in PubMed or wherever. And so this should come out next year, and will give you some more insight into the topic. And here is what I want to acknowledge also, the working group 7. When we last met a year ago in Winterthur, actually just about a year ago. Of course, in the meantime, we have not met in person. Maybe even next year we will not meet in person. But so they are developing all this method. You see here the project leaders that are, I think, in my view, are the most important people that actually driving the whole ISO process. And of course, I don't want to forget Brian Diffie. As also a few years ago, he came out with a book, Risk Management Approach. This is true for efficacy, but also for safety of sunscreen. So with this, I'm closing. And so I think I will then come back to the screen. Huh?
Yeah, that's what you do. So I'm sure.
Okay. There we go. Well, thank you so much for that. Boy, we got a ton of questions. There's a lot of great information there. And so we got just about 15 minutes more for doing questions. So if you have a question, we'll try to get to it, but we got a number of them there. I think, Uli, what I learned from this talk mostly is that the US sunscreens are kind of crap.
Well, I don't know. Well, I didn't want to say it like that.
I'm just kidding. Of course, they're better than not putting on anything.
But they certainly, in the world, there are other sunscreens that are better, I think.
Yeah, indeed. Okay, let's get to some of those
questions that were put in. This is a kind of a basic one, but Cecilia says, can you tell us why if you have the same SPF level of an ingredient, but you get a different effect? So say you are using that sunscreen simulator and you use X amount of avobenzone, but in one formula, you get an SPF protection of one thing, and another one, you get a different SPF protection. So what kind of would guide that beyond just the ingredient level?
Well, you talk about the difference of the simulated value and the real value. The simulation, of course, gives you a rather conservative value. This is actually in vivo calibrated. So these models are tested against in vivo SPFs. But these in vivo SPFs are the references. There may be some frame formulations from SIBA, from BSF, from DSM, right? And this is not the optimal formulation. So when you are a formulator at some company, then your challenge, or actually your goal, should be to be better than the simulator, always, right? But you can also be worse. I mean, if you don't consider that there could be, let's say, precipitation of a UV filter, then you're down, completely down with the protection. If you make a mistake like that, then the simulator is certainly higher, right?
Yeah. And certainly the way that you mix it,
The size of the emulsion particles, and lots of things about the formula can affect the film that gets put on the skin and the UV protection that you actually get. Okay, Shia Raha says, many sunscreens these days are using zinc oxide and titanium dioxide. What is your view on those ingredients as SPF protectors?
Well, we all, from the beginning, that was actually when we went on the market in 2000, and we were always seeing that if you have a synergy between inorganic and organic, right? So that is, for me, is still the ideal combination. You're not so much inorganics that it's whitening. It's actually aesthetically no longer, let's say, acceptable for most of the market segments. But maybe 1, 2, 3%, maybe more zinc oxide than titanium dioxide, but have this combination. And if you comes to when you don't want any other organic filters, then of course it's getting really difficult not to have any whitening at all, and at the same time have a very high protection. That's just getting more difficult, but it's a question of the segment, which is acceptable or not, right?
Let's go to nanoparticles, right?
That's a whole different topic.
Sure.
Yeah. Now, Leo, who is a frequent questioner, thank you, Leo. Leo says, what new data has come forward to make note of the possible toxicity and enhanced penetration with mineral sunscreens? So is there concern about the penetration of mineral sunscreens as far as toxicity goes?
Okay, I think that penetration is one thing, or actually permeation, and toxicity is another one, right? I thought a year ago when this proposed rule came out from the FDA that we are done now with this question, because they were clearly stating that it's not permeating, right? You don't find it in the body, and then you don't even have to worry about toxicity. I mean, there's obviously a hazard label from zinc oxide, for example, for transport. But this is a transport thing. When you have bulk of zinc oxide, or zinc actually, and that's in the environment and all that. But now we're talking about toxicity in the body. If it doesn't get into the body, then that's what the FDA says, right? You don't have to worry about it. And that's what I also thought. Even nanoparticles, they cannot enter the body. Period. I mean, that's my. And so you would actually think that people should look out for nano. I mean, nano or bigger particle, but the bigger particle, the problem is it's no longer so effective, right? But the nanoparticle is huge. I mean, you cannot show it here compared to any dissolved molecule, right? Any of these traditional filters that are solutions in the emollients.
Yeah, I think the evidence is that the nanoparticles, while they're small and we can't see them, they don't penetrate into the body.
Yeah.
Melissa brought up a popular topic on the sunscreen market these days. It's the idea of blue light protection. What type of work do you know that's going on in developing ways to measure the damage that skin might have from blue light? Is there anything like that?
There is certainly evidence. I mean, there's also pigmentation. You can discuss if that's a damage or not, but there's things going on, obviously, in the blue light and even beyond. But the question is then really, is it severe enough? Is it chronic? Is it what's really, that is not enough assessed, I think. But certainly the pigmentation is very clear. And that is certainly not desirable for many, right? And also there's some diseases that also, or melasma, for example, that maybe it's not deadly, but it's actually something that you don't want, and so it's fair to actually protect against, right?
Yeah. Do you ever see a time when
sunscreens are also going to start labeling for blue light protection?
I think some do already, but of course, I think there you have to look at the different regions. I guess in the US you cannot just do that, right? You have your strict regulations, what you claim and what not, and in Europe and other jurisdictions, it's just you have to prove and you have to substantiate what you claim.
Yeah,
and that the authorities can come and ask you, where is the data, right?
Yeah, absolutely. All right, we've got about 5 minutes more for questions. We've got a few in, but if you have one, feel free to put it there. We might get to it. Nalam says, does this mean that in vivo standard SPF testing is not sufficient?
In vivo standard alone is not sufficient, that's for sure. Yeah, because I'm now talking about the UVA part, is just not covered enough. That's what I mean is not sufficient. And that's why we have invented for a long time now already this all these different UVA methods, right? Where they, like the FDA or Australia, they decided, US a bit later and Australia earlier, that in vitro is good enough, right? And we don't need an in vivo UVA, right? But that's the reason we had to have some assessment of UVA, because the same SPF, 15, 30, I showed the example of 15, at 30, actually 40, it's not possible anymore to have no UVA protection at all. That's not possible, right?
Okay.
Because the UVA is also inducing erythema.
Right.
And so that's just not possible. If you have a 30, then you have to cover sufficient UVA not to get the erythema from that UVA.
On the topic of UVA, Saeed says, are skin cancer or skin agings damages attributed to UVA more in the US compared to that in Europe? So I guess if we look at the marketplace and the products that people are using, you had pointed out that the US doesn't block as much UVA or give as much UV protection. Is that manifesting itself in some sort of outcome metrics like skin cancer, increased skin cancer, or skin aging, or anything like that? Is there a way we can measure the differences there?
I think that's a very good question, but also a very difficult one. We have actually a chapter in our book there from Diane Goddard, and she has looked at the epidemiology of different regions, right? With northern, southern, with different exposures. And I don't know if you cannot take really into account exactly how much sunscreen everybody's using, because nobody has this data. But there, the clear conclusion is that UVA plays a role in melanoma, especially in melanoma. Not so much in non-melanoma skin cancer, but in melanoma. But really, I myself have to digest that paper, and she just put it together. It's here as a manuscript. It will come out, and this is she has written about that before, and it's this epidemiological data that really can tell you something. But the exact study with sunscreens and without sunscreen and so on, yeah, it would be great to have this data. And in Europe and in it's also the compliance. I mean, how many US and how many European citizens actually use sunscreen, right?
Yeah, it's an interesting one. I saw, I think I saw a paper where they compared SPF 50 to SPF 100, and the complaint is that, well, 100 makes it seem like you get twice as much protection when you only get a percentage more. But this paper, I forget which the paper was, but they had suggested, well, it doesn't protect that much more. You actually do see a difference between people who use 100 SPF versus a 50 SPF.
Well, if you do that in the laboratory, I mean, what it clearly shows, 100 does protect twice as much as 50. But this is against the laboratory sun. Huh?
Yeah.
Right?
Exactly.
And I think these people have also done studies outdoors, and they just compare 100 with and outdoors. It's again a bit a different story, but and it's, as we showed now in the paper together with Brian Diffie, you cannot really talk about maybe 100 anymore against the real sun, right? So that is probably not even possible, right? Not even a 50. That the 50 is maybe 25, but 25 is actually a good protection, right? So we have to maybe eventually, but as I said in my talk, this is really is coming in the next years, maybe to come, but not yet discussed. Now we want to have these methods in place, have it normalized, in standardized in ISO. So that's the short-term objective here.
Yeah. All right. I think we got time for 2 more questions. Sorry if we don't get to your questions. We'll certainly collect them and give Uli a chance to answer them offline. But here's one from Steve. He says, is there any information on how in-silico has improved to account for base product or film former effects? For example, not the active ingredient or booster inclusion, but are the film formers or the viscosity increasing agents? Are they, could in-silico predict for that?
Well, I was involved, like as I said, from SIBA and BSF, and there we did not yet really consider that a lot. But it's a very good question. The film forming, I mean, the better the film on the skin, the better the SPF. That's for sure, right?
Yeah.
And so that's what my point is. When you compare this in-silico model with this like a kind of standard products which have maybe not that optimized, then it should always be lower, or actually you should be able to top this a lot by very good film formers. But incrementally, it will still give you a lot of good information. I mean, you will back your formulation then against in vivo, and then the in-silico gives 30, but actually I had measured 50. So you can work with that difference in your lab, right? And use this in-silico data also still a lot.
Okay, our last question comes from Audrey. Before we end up, thank you, everybody. Thank you, Uli. Thank you for participating. We'll be back in 2 weeks with an A-Beauty webinar. Very interesting. Okay, last question from Audrey. Audrey says, does the HDRS method apply to sunscreen products containing mineral filters?
It applies to all types of products that you actually can put on the skin. And then obviously there is no sunscreen that you cannot put on the skin. This is the definition of sunscreen. It can be a stick, can be whatever, and whatever is then on the skin can be measured on that skin, right? So that's as simple as that, actually.
All right. Well, Uli, we come to the end of the hour. We've come to the end of this webinar. Thank you so much. Very educational. Everyone is going to receive a link to the... Well, we still have over 300 people online. So thank you, everybody, and we'll see you next time.